Ever wondered about the origin of our universe? What caused the massive explosion that resulted in the world as we know it? Well, sit tight and prepare for a cosmic journey back in time, way back, to the very beginning. We're talking about the Big Bang Theory, the prevailing cosmological model that paints a picture of our universe's origin story. The Big Bang Theory isn't about a bang or an explosion in the traditional sense. Instead, it's the concept that our universe began from an extremely hot and dense point roughly 13.8 billion years ago. This point, often referred to as a singularity, was so scorching and compact that the laws of physics as we know them didn't even apply. Then, in an instant, this singularity began to expand, and I mean really expand, at a rate faster than the speed of light. This rapid expansion, known as cosmic inflation, created the vast cosmic landscape we call our universe. But it wasn't an explosion in space as many often imagine, but rather an explosion of space. Space itself was, and still is, expanding. And within this rapidly expanding space, particles began to form, eventually leading to the matter we see today. As the universe expanded, it also cooled down. This cooling led to the formation of subatomic particles, and eventually, simple atoms. Over time, these atoms came together to form stars and galaxies, setting the stage for the cosmic spectacle we see when we gaze up at the night sky. Just imagine, all that we know, everything we see, touch, and experience, all started from that tiny, infinitely hot and dense point. So, the Big Bang Theory explains the birth of our universe, but what happened next? Stay tuned as we delve into the formation of galaxies, the birth of stars, the creation of planets, and the evolution of Earth and life itself. Following the Big Bang, the universe began to cool and expand, leading to the formation of galaxies. But how did that happen? Let's dive in. In the aftermath of the Big Bang, the universe was a hot, dense sea of particles. As it expanded, it cooled, and the particles began to clump together under the influence of gravity. These clumps of matter, primarily hydrogen and helium, were the seeds from which galaxies would grow. These seeds weren't evenly distributed though. The universe was a bit like a giant sponge with denser regions separated by large voids. Within these denser regions, gravity went to work, pulling matter together into ever bigger clumps. These became the first galaxies. But the process didn't stop there. The first galaxies were small and irregular, nothing like the majestic spirals and giant ellipticals we see today. Over billions of years, through a process known as hierarchical clustering, galaxies merged and grew, evolving into the diverse array we see in the universe today. Imagine two galaxies, each a swirling mass of stars, gas, and dark matter, drawing closer under the pull of gravity. They collide, their stars swirling around each other in a cosmic dance. Over time, the galaxies merge, their stars settling into new orbits, their gas clouds igniting to form new stars. The result is a bigger, more complex galaxy, different from its progenitors but carrying their legacy within it. This process of collision and merger has shaped the universe we see today. Our own Milky Way galaxy, for instance, is the result of many such mergers, and is on a collision course with the nearby Andromeda galaxy. But don't worry, that's not due to happen for another 4 billion years or so. So, from the seeds planted in the early universe, through the action of gravity, and the process of hierarchical clustering, galaxies were born. These cosmic cities of stars, gas, and dark matter are the building blocks of the universe. They are the places where stars are born, where planets form, and where perhaps life begins. Galaxies were born, setting the stage for the formation of stars. In the vast cosmic nurseries of galaxies, stars began to form. But what causes a star to be born? Stars, these twinkling beacons of light, begin their life in a much less glamorous fashion. Their birthplaces are cold, dark clouds of gas and dust, known as nebulae, scattered across the cosmos. These are not just ordinary clouds, but vast, sprawling expanses of space material, some stretching hundreds of light years across. Now imagine a disturbance, perhaps a nearby supernova explosion, causing a ripple through this nebula. This ripple triggers the gravitational collapse of a portion of the cloud, forming a dense core. As gravity pulls more and more material inward, the core becomes increasingly dense and hot. This core, or protostar, continues to grow, drawing in surrounding gas and dust. As it does, the pressure and temperature at its heart rise dramatically. Eventually, the temperature reaches a critical point, over 10 million degrees. At this scorching heat, something extraordinary happens. Hydrogen atoms begin to fuse together to form helium, releasing an immense amount of energy. This process, known as nuclear fusion, is what lights the star. turning it from a dark, dense core into a glowing beacon. Stars like our sun don't just shine, they also create. The gravitational pull of a star draws in dust and gas from its surroundings, forming a disk around it. Over millions of years, particles within this disk collide and stick together, gradually forming larger and larger bodies. These bodies, given enough time, can form planets, asteroids, and comets, creating a planetary system. In this way, stars are the cosmic factories of the universe, turning simple elements into complex ones, lighting up the dark voids of space, and providing the building blocks for planets and, potentially, life. Stars lit up the universe, and in their midst, planets began to form. As we continue on this journey, we'll explore how these planets evolve and how our own Earth came to be. In the swirling dust and gas around young stars, planets began to take shape. But how exactly do they form? Well, the tale of planet formation is a cosmic dance of dust, gas, and gravity. It all begins with the remnants of a newborn star, a swirling mass known as a protoplanetary disk. This disk is composed of particles of dust and ice, leftovers from the formation of the star. These particles, tiny as they may be, have a significant role to play in the grand scheme of things. They start to collide and stick together, gradually forming larger and larger clumps. Over time, these clumps grow into planetesimals, the building blocks of planets. In this chaotic cosmic dance, these planetesimals continue to collide and merge, creating protoplanets. These protoplanets, still in their early stages, are hot and molten due to the heat generated from the constant collisions. Now let's fast forward a few million years. The protoplanets have cooled down and solidified, but their journey isn't over yet. They continue to attract more and more material from their surrounding environment, growing in size. For rocky planets like our Earth, the process ends here. But for the gas giants, there's another step. Once these protoplanets become massive enough, their gravity starts to attract and hold on to gas from the surrounding disk. And voila, a planet is born. But it doesn't stop here. The newly formed planet continues to evolve, its surface shaped by geological processes and in some cases life itself. This process, as complex and chaotic as it may seem, is how planets are formed. From tiny dust particles to massive celestial bodies, every planet has a story to tell, a story that is intricately linked with the birth of its parent star. Planets formed around stars, creating the diverse cosmic landscape we observe today. From the gas giants of our solar system to the rocky exoplanets orbiting distant stars, each planet is a testament to the beauty and complexity of the universe. One such planet, our Earth, developed conditions suitable for life. But how did life emerge in this once barren world? In the early days of its existence, Earth was nothing more than a hot, molten sphere. Amidst the chaos of colliding space rocks, a thin crust began to form over the surface. Over billions of years, the cooling and hardening process continued, shaping the Earth into a solid body with a stable climate. But still, it was a world devoid of life. How then did life spring forth from this lifeless sphere? The answer lies in a blend of chemistry, physics, and a bit of luck. One popular theory is the primordial soup theory, which suggests life began in a warm pond or ocean as a result of the combination of chemicals from the atmosphere and some form of energy, such as lightning strikes or volcanic eruptions. These elements combined to form the simple molecules that are the building blocks of life, which then evolved into the complex forms of life we see today. But there's also the panspermia hypothesis, which posits that life did not originate on Earth at all. Instead, it suggests that life, in the form of simple microorganisms or life's building blocks, traveled through space and landed on Earth, kickstarting the evolution of life here. Both these theories, while different, present a fascinating perspective on how life began on our planet. From a world of molten lava and colliding space rocks, Earth transformed into a lush blue planet teeming with life. From microscopic organisms in the depths of the ocean to towering trees reaching for the sky, life found a way. And so in the vast expanse of the cosmos, on a tiny speck of dust suspended in a sunbeam, life began to flourish. The evolution of Earth and life is a testament to the resilience and adaptability of life forms and the miracle of existence. From a speck in the universe, our world evolved and life, as we know it, began to flourish. In this cosmic journey, we've traversed from the Big Bang to the emergence of life on Earth. We began with the Big Bang, that singular point of infinite density which exploded and gave birth to our universe about 14 billion years ago. From this cataclysmic event, galaxies formed, colossal systems of stars bound together by gravity. Then we delved into the birth of stars, those brilliant celestial bodies that light up the night sky. We explored the formation of planets, celestial bodies orbiting stars, including our very own Earth. We saw how Earth evolved, how it transformed from a molten mass to a vibrant life-sustaining planet. We witnessed the emergence of life, from the simplest single-celled organisms to the complex biodiversity we see today. So, that's our journey, from the very beginning to the world as we know it. The next time you gaze at the stars, remember you're looking at a story billions of years in the making.